Thank you. Thank you. So what I have here is the best image you want to see before lunch. Namely, this is what we call in Austria a Krapfen. Some people call it a Berliner or something else. There are different terms in Germany. And Krapfen are mainly used during Carnival, not only, but mainly. And you can imagine them as a donut without a hole in the middle. We don't have a hole, because normally we fill them with jam, and a hole would be quite counterproductive there. And as those guys are used mainly during Carnival, some people always try to be funny and don't fill them with jam, but with mustard. Yeah, that's really mean. They pick out one of them and exchange the jam by mustard and put it back. And then it's kind of a lottery for you if you choose the one with the jam or with the mustard. And if you choose the wrong one, you have a bad experience. As you can tell, Krapfen and mustard don't go together that nicely. So this is really mean, but quite a habit there. And I think it shows that even a small change can have a huge impact. And perhaps this is also the case for exchanging Redux by something else. I think all of us know Redux. For some time, it was the go-to solution for state management, but nowadays it's challenged. We have a lot of alternatives there, a lot of lightweight stores, and perhaps we have such a situation when we exchange a Redux-based store for a more lightweight one. And this is what I want to investigate here in this session. I want to tell you what will change when you go with a lightweight store in terms of your architecture. If you are wondering what I'm referring to when using the term lightweight store, well, it's basically some kind of store that provides just methods. I can call those methods. They will trigger some action. It can be an synchronous or an asynchronous action, and this action will lead to new state. New state that is propagated down using, observables or signals or something else. And out there is really a huge range of such stores. Here you find some of them, but there are even more. Perhaps you have looked into Solid.js. Who is using Solid.js? Okay, almost no one. But also Solid.js comes with such a lightweight store out of the box. It's baked in. So what's the agenda of all of this? Well, I want to start with a baseline architecture. A first architecture we will use for discussing how such a lightweight store can change our architectures. Then I want to answer several questions like how large should it be, where to put it, and also what to do with global and or local state. Another question is about preventing cycles, redundancies, and inconsistencies, something Redux is really great at, isn't it? For some reason, I hear myself here. Let me just check this out. Okay, great. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm doing a lot of trainings and consulting. And besides this, I'm also quite connected to the Angular community. I live in Austria. This is where we have Krapfen, as you know, meanwhile. But I also do a lot of stuff in Germany and all over the globe. I'm always happy to work together with people around the globe, remotely or on site. Okay, cool. Let's get started with my baseline architecture. And as I'm an Angular guy, I will use an Angular-based stack, but no worries. If you don't use Angular, everything I'm saying here will also apply to your stack, because all of this is more on a conceptual level, on an architectural level. But here I'm going with Angular and the so-called NGRX signal store, which is quite a new store and a quite nice example for a modern lightweight store. So what does my architecture look like? Well, the thing is, we are working together with a lot of huge enterprises, And so what we always try is to decouple or to subdivide our applications into something we call business domains. Business domains are areas from the real world we try to mirror in our application. And perhaps if you write an application for airlines, you might have a booking domain and a boarding domain, and you might have some shared stuff in there, stuff that is used in all the domains. And then we start to fill those domains that can be parts of our mono repository, just folders or libraries. We fill them with so-called modules. And also those modules can be just folders or packages, libraries, as you wish. We have categorized those modules. For instance, we have feature modules with smart components. We have UI modules with dump components. They are more reusable. That's why we put them into separate modules. We have data modules for data access and data structures, and we have utility modules for general purpose utility functions like authentication or calculating dates, stuff like this. And having an architecture like this matrix, has several advantages. First of all, it brings a lot of order into play. There is less discussion about where to put something and where to find something. Discussion about this is nothing you need when you have a large team or several teams working on this. Then it should be clear where to find something and where to put something. This is one advantage. Another advantage is you can now introduce simple but very effective rules, like you can only navigate top-down here, which means that feature can access everything below it, which would be UI, data, utility. And also data can only access everything below it, which is just utility. This prevents 4 cycles, and this makes sure that not everything is intermingled with each other. Talking about preventing that everything is intermingled with each other, perhaps this here is the more important rule, where we say that code from one domain is only allowed to talk to other code from its own domain and with shared code. So in this case, booking is allowed to talk with booking stuff and with shared stuff. Boarding is allowed to talk with boarding stuff and with shared stuff. Booking and boarding are not allowed to talk to each other. This also prevents that everything is intermingled, that you change something here and break something over there, which is quite an awful situation. The thing is, somehow we need to enforce those rules. And for this, we could go with Sheriff, which is a nice open source project a colleague of mine wrote. And it allows you to define that this folder is only allowed to access stuff in that folder, to import stuff from that folder in terms of ECMAScript modules, but not from these folders over there. And now let's have a look into a first demonstration about all of this. So for some reason, I still hear myself here. Why is that? Okay, good. So let's have a look into an example. Perhaps it's this guy here. I'm not sure. But what we have here is a very simple example. And this simple example is for searching for flights. You can click here and then you can book your honeymoon. London, Paris is a typical honeymoon, someone told me. And yeah, then we find some flights. So it's really as easy as possible, but as complex as needed to show all those concepts. If we look into this application, we see here our flights application, and it has a domain folder. And if we drill in, we see all our domains, all those areas from the real world we want to mirror in our application, and we want to decouple. Perhaps different teams work on them, so we really want to decouple them. We have here check-in, luggage, the shared stuff, and ticketing. And in here, we have 3 libraries in 2 layers. We have 2 libraries from the feature layer, and we have 1 library associated with the data layer. And if we drill in here, feature booking, then we see here a component flight search. And you see a lot of ECMAScript imports. However, this one is not allowed, because here I'm in the ticketing area, in the ticketing domain. I'm not allowed to grab over to a foreign domain that might be supported by a different team and import something from there. It's like going into a different building and taking something out of the fridge. It's not considered that polite in most countries I'm aware of. So if we really try to import stuff here, sheriff, which is basically a linting rule, tells us, hey, Manfred, what you are doing here is not allowed. You don't have a clearance for grabbing over to there. And this is great, because this allows us to enforce our architecture, and this makes sure we don't have any broken windows anymore. You can also use this like a unit test when someone wants to land their pull request. If they violate this rule, then they are not able to land their pull request. Besides this is a simple component. It is using a simple store. It is delegating to the store in terms of getting some data from the store. In this case, it's signal-based data, so it's reactive. From will tell us when it has a new value, and to will tell us when there is a new value. And in terms of methods, we are just also delegating to those methods. So we are sending a method up and some data comes down, really a simple, lightweight solution. Okay, so this was our baseline architecture. And now the big question is, how does this all affect the way we are working? And the first question that might come up there is, how large should it be? How large should such a store be? And this is quite an interesting question, because if we talk about Redux, it's class clear. Then the Redux store contains everything. Then we have one big store, one single source of truth. When it comes to lightweight stores, we very likely have several of them, because a store is something like a file or a class, something that provides methods and data structures. And so we are here on a feature level. That means we need several lightweight stores, one per feature, or if this feature grows too huge, we need one per sub-feature. We break it down into parts of our features. And this might be necessary because everything that belongs to a lightweight store is usually put into one file. This is also a big difference to Redux, where we have several files that describe the whole store structure, the reducers in there, the actions, and so on. So we are here on a feature level or a sub-feature level. The next question is where to put the store. And this question should be seen in the light of this architectural matrix. Also here, funnily, if we talk about Redux, the answer is quite clear. Because Redux has a notion of a feature slice. And so it's somehow clear that the feature slice is associated with the feature level. And sometimes people put it to the data level because they say, well, perhaps we have several features that need the same state. Perhaps we have several features in booking that need your tickets. Then we just pull it down. So in the case of Redux, it's class clear one more time. In the case of lightweight stores, this leads to an interesting discussion. When we have a lightweight store, for instance, the store can live on a component level. Some people want to offload the state management from their components to make them simpler, and so they might just create one store per component. This is very local state for very component local state. It's an option. Some people might tinker a store for a feature, as mentioned before. Everything that is needed by this feature, by all the, let's say, 5 components of the feature goes in there. Some people might say, well, we have several features that need the same state. And so they might put it to the data level so that several features of the same domain, perhaps of the booking domain, can access it. You might even have state on the utility level. Not always, but it's possible. Not all utilities are stateful, but if we think about something like authentication, we for sure have a state there, the authenticated user and so on. So somehow we need to manage it, and we could do this by means of a store. And the last one is really funny, because it turns out that a lightweight store can also live in a dump component. And this sounds like a no-go at first glance when we come from a Redux perspective. Because in Redux, it's really a no-go that a dump component can access the store. But this is mainly because in Redux, we have global state in the store, application-wide state. And this is not the business of the dump component. However, a dump component can have some state of its own. Think about a scheduler component. It can be quite complex. It consists of a lot of subcomponents. And so it has a lot of states to manage, all the dates and the different options of dates and all the flags for the dates. And so we could really decide to have a little own store to manage this complexity for our scheduler component. However, the big difference here is this is an implementation detail of the dump component. So the dump component is not exposing the store. It's really an implementation detail, and it's not of none of our business if we are on the feature level. That means, and this is somehow funny, if you come from a Redux perspective, a lightweight store can literally live everywhere. We can define it for a component or for a whole module. And if we define it for a whole module, we can decide to expose it for other modules, or perhaps it's an implementation detail of the module. The next big question is what to do with global state and how to distinguish global state from local state. Well, here we are lucky, because we can really have stores on all the different levels, on the feature level, but also on more global levels. However, in this case, we might have the challenge that a feature needs states from different levels. Perhaps we need some state from the utility store that is managing my user data, and some state from my own feature store. And in this case, we can introduce a service or just a function that is orchestrating all those stores. Let me show you a simple example for this. So what I have here is your next flights. And obviously, to show you your next flights, I need to know who you are. That means I need your user ID from the utility store that is about authentication, and I need to know your flights, which are managed in the feature store of this very feature. So how can we accomplish that? Well, basically, we just need a function or a class or a service, it does not matter, that is orchestrating all those stores. Here I'm grabbing my out store, here I'm grabbing my ticket store. When I want to load something, I'm delegating to my ticket store. And here you see I'm calling load by passenger, and I pass in the current user ID from the out store. And as I has signals, I can also use those signals to compute new signals. It does not even matter where those signals come from. They can come from different stores. I can just compute the results of those signals together. For instance, here, I'm projecting the tickets of the current user to the flights that are associated with the tickets. So I think the key takeaway here is, if you go with lightweight stores, you might have a situation where you need to orchestrate several stores. The last question I want to answer is how to deal with cycles, redundancies, and inconsistencies. Well, and the answer is layering. These rules we have that one layer is only allowed to access layers below really helps to prevent cycles. And we can even introduce another rule that one store is not allowed to access further stores. In this case, we also prevent a situation where we need something from each other in a cyclic way. And of course, we need some dev tools, like the Redux dev tools, that show us where we have which data. And so we can find out about redundancies and inconsistencies. But also this last point is not that different from the Redux world. Because in the Redux world, when you subdivide everything into feature slices, you also could get redundancies, especially if another team is responsible for the same or for another feature slice. So also in this case, you need a way to observe the state in your system. And for this, the Redux dev tools are really great. And saying this, most lightweight stores also have support for the well-known Redux dev tools. So if you like those ideas I had there, you find even more in this free ebook. Feel free to download it. And now let's come to the conclusion. We have seen that a lightweight store has the size of a feature or a sub-feature. We have seen that it can live literally everywhere. We have seen that we can orchestrate several stores, and sometimes we have to orchestrate them with a, I call it feature service. In your case, it's perhaps just a file with functions, if you go with a more functional approach. And we have seen that layering prevents cycles. Also, we should use the dev tools. And there is a last thing I really want you to remember. Please, please always remember this very last thing, namely Krapfen and mustard don't go together. Please prevent this joke. So thanks for having me. Here you have my contact data. Feel free to follow me on X, and I've already uploaded my slides and examples to my blog. Thank you.